Welcome. I'm Collins Trott, Child Development Faculty on the Wallace Community College Dothan campus. In this episode, we're going to be learning about new directions in learning. The study of children has changed over the years. The scientific study of children emerged from the field of psychology. During the last half century, child development research has focused mainly on the cognitive theories of Piaget and Vygotsky. Although these theories are still being researched, the new research frontier of the 21st century is brain studies. Researchers have long been interested in the brain, but major technology advances allow for much more precise study. Because these studies are rather new, what findings come out today may be updated tomorrow. So join me, Miss Trott, as we learn all about new directions in learning. Brain development begins shortly after conception. Full-term babies have about 100 billion brain cells. However, it's the least developed organ at birth. Brain growth happens when brain chemicals are released in waves. Brain growth occurs in a predictable biological sequence that is the same for all people. The brain is made up of two types of cells, neurons and glial cells. Neurons send and receive chemicals and electronical impulses among each other to direct the various tasks of the brain. Glial cells are brain cells that support neurons. Each area of the brain is highly specialized. In the beginning, neurons that we need to make connections will be near to each other, but later neurons can grow very long axons to reach distant neurons. The network of fibers that carry brain signals between neurons is called wiring. As soon as sections of the brain are wired, connections must be sorted in a step-by-step process called learning. People's experiences affect wiring. Wiring that is seldom used is pruned to make stronger connections elsewhere. If needed, new wiring can also be made. Pruning begins in the very first years of life and is almost completed by 10 years of age. The brain has the ability to change or adapt to the environment, and this ability to be reshaped is called plasticity. Although the brain is plastic, timing is an important concept when it comes to brain development. The entire brain is not wired at one time. Today, brain researchers use brain scans to note optimal times for making connections. They note two types of periods in wiring: critical periods and sensitive periods. Critical periods are times when some part of the body is very vulnerable to the lack of stimulation or to negative experiences. Sensitive periods are times when the brain is best able to wire specific skills for all children. Knowing when the brain timing for various skills occurs helps parents and teachers offer the right kind of experiences for a child at the best times possible. This is called using the windows of opportunity. In this windows of opportunity, a child reaches a peak capacity to learn the skill if given the opportunity. On the other hand, if the child does not receive the right stimulation within the given time frame, these times of windows of vulnerability where child development is likely to be impaired. Cutting-edge science on brain development confirms what many parents and caregivers have known for years. The earliest years are the most important for all areas of growth and development, and all experiences affect the brain's performance. The brain is part of the human body. Nutrition, physical activity, and general health all affect a person's brain. Without quality early childhood experiences, the brain connections can be pruned too much and the windows of opportunity are missed. Child development involves the study of children and the adults in their lives. The first goal of child development research is to advance knowledge. The other goal is to apply knowledge. Today, schools are teaching 4 types of knowledge needed now and in the future. Explicit knowledge refers to knowledge about facts. When children learn to name colors, shapes, animals, and objects, they acquire explicit knowledge. Implicit knowledge refers to skill-based knowledge. Young children begin acquiring implicit knowledge when they learn to ride a bike, swim, or balance blocks. Scientific knowledge refers to the ability to create knowledge. This type of knowledge underlies new technological development, scientific discoveries, and process advances. Acquiring scientific knowledge begins when young children try different actions with their toys. Knowledge about experts involves knowing who has the other forms of knowledge. Mastering this type of knowledge requires understanding what knowledge is needed, knowing who has this knowledge, and building social relationships to get access to the experts and their knowledge. Young children acquire this knowledge and quickly learn which parent, sibling, or friend has the knowledge or skills they desire. For people to reach their full potential in school, in careers, and in their personal lives, they must not only acquire knowledge, but make good use of it. Executive functions are the intellectual functions people use to manage themselves and their resources to achieve goals. Executive functions are used in achieving all tasks and include working memory, cognitive flexibility, and inhibition. Child development knowledge is being applied not only by educators, but also those in health and protective services. Children are not born with the ability to control the harm that may come to their developing bodies, including their brains. Many children come into the world of loving parents, plentiful food and other necessities, and a supportive environment. Other children, however, are born into a world of less than responsive parents, scarcity of food, and lack of other necessities, and a harsh environment. By nature, children are survivors, but people must nurture and support each child. Applying what you know from child development research can have powerful impacts on all children. Doing what is right for children is their best insurance for their future as adults and in the next generation of children. Now let's review what we've learned. The study of children has changed over the years, and the new researcher frontier of the 21st century is brain studies. Brain growth occurs in waves, and the fastest growth is during the prenatal through early teen years. The brain is made up of neurons and glial cells. Neurons are connected with sensory organs and with the brain. Glial cells support neurons. Neurons are connected through wiring, which allows communication to travel from neuron to neuron in a specific order. People's experiences affect wiring, and wiring can change due to the brain's plasticity. Wiring that is seldom used is pruned. If needed, new wiring can also be made. Periods of fast brain growth signal windows of opportunity for learning certain skills. During these times, the brain is also more vulnerable and needs more protection. Today's world requires children to adapt to many changes. Schools prepare children by teaching explicit knowledge, implicit knowledge, scientific knowledge, and knowledge about experts. To sequence content and determine the best way to teach, schools often look to the theories of Piaget and Vygotsky. Schools also try to help children use knowledge effectively by strengthening executive functions and life skills. Child development knowledge is being used by workers in health and protective services. Many children are vulnerable to countless stressors. Child development knowledge is being used to prevent and treat children's stress. That wraps us up for this episode. You can learn more about this topic by reviewing the resources posted in your course. As always, if you have any questions, please contact your instructor. Thanks for joining me, Miss Trott, as we learned all about new directions in learning. See you next time.